Okay, so this is another one where I want you to take a minute and look at the packet, look at the blanks. I've got them numbered here, 1, 2, 3, and then we have some more down here, 4 and 5. And the answers, I just want you to guess what goes in those blanks. If you can guess, then great. And if not, you've already primed your brain for what those terms should be called. So go ahead, pause the video for just a second and give it your best guess as to what word would go in those blanks. Okay, so first of all, this first pyramid, which is our shape for the day, we're doing lateral area and surface area pyramids, has a single vertex. It has that single point at the top. Sometimes it's called an apex, but we're going to call it a vertex at the top. All of the sides, if you hadn't noticed, they're all triangles as opposed to rectangles like the prism. And the base is always going to be a polygon. And we're going to see here in a minute that all of the pyramids that we study are all indeed not just going to be any old polygons, but they're going to be regular polygons. All their sides are going to be equal. All their interior and exterior angles are going to be equal to each other. Okay, so just like we had with the cone, we're still going to have that height going up the middle of the pyramid, which is going to be the altitude, which is going to be our height of the pyramid. And then we're going to also have slant height, which is going to be also an altitude, but here's what's confusing. This is the altitude of the side triangle, or if you want to call it the lateral triangle, right? So it's a different kind of altitude. It's not the altitude of the pyramid, it's the 2D altitude of this triangle that is on the side of this pyramid. So that is awfully confusing in my opinion. Just like before, the slant height is on the side and the altitude is the one going up the middle. So what it says is just as with the cone, there are two types of height on a pyramid: traditional height, the one going up the middle, and slant height. Use your pen and pencil to represent the height of your pyramid. Now use the dry erase marker. So if we had been in class, and unfortunately we are not, I would have given each of your groups a three-dimensional plastic pyramid, and we would have all stuck our pens and pencils up the middle of those pyramids to show the actual height, and then you could have used the expo marker to draw on the side of that pyramid that slant height. Unfortunately, that activity doesn't work so well on a video, but you could have, here you go, you could have drawn in your slant height. And we'll still use the letter L for that. Okay, so two types of height. We said the actual height, the traditional height, is the segment from the vertex, starts at the top, and goes to the base. So it's this guy going perpendicular to the base. And then the altitude of each triangular face is the slant height. And it makes sense that we would call it the slant height, right? Because it's slanty. It's on the slanted side of the pyramid. And just like with prisms, remember, pyramids are going to be named for their bases. All right, so multiple kinds of pyramids. We've already kind of been talking about slanty shapes, oblique things. Where there's oblique pyramids, and then there are right pyramids, just like we've talked about. There's also, then within that category, there's also regular right pyramids, and then there's non-regular pyramids. So the base of a pyramid can actually be the same all the way around, or it can be different side lengths. In this case, it's concave on the base, and technically the same thing can happen for prisms. It sometimes pops up that you don't have a regular base, and I just wanted you to know we are only in this class going to deal with regular right pyramids, at least for surface area. We will not deal with the oblique or the non-regular right. All right, so if you'll pause right there, I'll see you in the next video.